All right, we're going to talk about the three laws of thermodynamics. The first law says that energy of the universe is constant. The second says that entropy of the universe is always increasing, and I'll explain what entropy is in a moment. The third law says the entropy of a perfect crystal at 0 Kelvin is always 0. And thermodynamics determines whether a reaction will occur or not based on the math. So let's look at the math. When we're doing our calculations, enthalpy is your H, and that is the heat or energy of a reaction. It is either endothermic or exothermic. So if it is endothermic, it's going to be a positive H. If it's exothermic, it is a negative H. Two of the ways that we can calculate that, the Q equals mc delta T and Hess's law, are two ways we've already been dealing with calculations. A new formula is we can take the H of the products minus the reactants, and that's where you look at the table that I gave you in class. Entropy is represented by S, and that's a randomness or scatteredness. One way to calculate it is through Hess's law calculations. Or we can look at our table and look up the numbers for the products and subtract the reactants. We're going to do practice problems on these. And the last thing is Gibbs free energy, and that takes in your total energy involved. It takes into account the enthalpy and entropy. It can also be calculated through Hess's law process, through the products minus your reactants. And more commonly, we use delta H minus T delta S, where T is your temperature. So if we want to calculate the delta H for a reaction of nitrogen monoxide and oxygen to form nitrogen dioxide, first thing we have to do is write and balance the equation. So we have 2NO plus O2 goes to 2NO2. Then we look up the values on the table that you have been provided. And we see that NO is 90.37, and that's in kilojoules. Oxygen and all elements at their natural state are 0. And NO2 is 33.85. So then we subtract the sum of the reactants from the sum of the products. And so you see that I did have to take into account my 2's. So the coefficients, we take those and multiply them by the numbers that are from the book or from the paper that you're given. And it's the total of your products minus the total of the reactants. And on here I got a negative 13.04, so this is exothermic. An entropy example, if we want to find out what occurs when 1 mole of water gas condenses to water liquid. First we write the equation, then we look up the values, and you can see that the gas has a higher value because it's more scattered, and that's what we want. Substitute the numbers in, and so we take our product, which was liquid water, minus our reactant, and we have a negative 118.8, and that's joules per Kelvin. So this is a non-spontaneous thing. We have to lose energy. Remember that the second law says we want more randomness in the universe, so that's considered non-spontaneous. It has to be a positive number, positive S, for it to be spontaneous. So how do we know whether a reaction is going to occur? Spontaneous reactions favor the products, and they move from an ordered state to a more disordered state. So this is ordered, and this is disordered in that order of so solids to liquids to aqueous to gas or vapor. Non-spontaneous reactions favor the reactants. And your enthalpy, or your heat, and your entropy both contribute to whether a reaction will occur. And that goes to your delta G equals your delta H minus T delta S. So whenever if we have exothermic reaction and it's getting more disordered, then it is definitely going to occur. It is a spontaneous reaction. And spontaneous does not mean instantaneous. It means it will occur. If we're having to put energy into it and we're getting solids or liquids are getting a more ordered state, then no, the reaction will not occur regardless of the conditions. And then you have the other combinations, and that all depends on how that multiplies out. So our Gibbs free energy example is we're going to use the values for delta H and delta S to determine whether this reaction is spontaneous or not. So the first thing we have to do is look up all of our values. So I looked up all my H values and I looked up my S values. I calculated delta H and delta S like we did on the two previous slides. So doing the products minus the reactants, and those are the numbers that I got. Third thing you have to do is convert your temperature to Kelvin and your delta S to kilojoules. So to convert our Kelvin, it's 25 degrees. Here's my 25 degrees plus 273. That's always add 273. And I get my 298. And to go from joules to kilojoules, we move the decimal 3 places. So that's how we ended up with our decimal. And then we plug our numbers in, and we find out that it's a negative 394 because it's negative. A negative delta means a negative delta G means it's spontaneous. And the other way that we can calculate delta G is looking at the data in the table and doing our products minus reactants. So we've got our equation. We look up the values into the table, and elements in your delta H and your delta G, they are 0 in their natural state. And we substitute the numbers in. We see that it is a positive number there, so therefore it is non-spontaneous.